Okay, YouTube, in my last video we discussed how to find the equation of a line using what we call point-slope form. In this video we're going to use a more common form of a line that we refer to as the slope-intercept form of a line. And I say here that another extremely convenient way to express the equation of a line is called this slope-intercept form. And I say this can be obtained by using the point-slope form of our line, but if our fixed point is actually the y-intercept of the graph specifically. So when we allow the fixed point here, that would be when we're talking about point-slope form, this x1 and y1 pair here. If we allow that to be the y-intercept of the graph, again, this is our x1 and this is our y1, what this does is it leads us to a pretty simple conclusion. You can see when we plug this in here, say we have the slope m, and that our point x1, y1 is actually this point 0, comma b. What we'll do is we'll insert 0 in for our x1 value, you can see that right here, and we'll insert b in for our y1 value, which b, recall, is our y-intercept. And what this leads us to is essentially a statement that says y minus b on the left and m times x minus 0 on the right. But recall that anything in a sum or a difference with 0 becomes itself. So really we get y minus b equals m times just x, and adding this b with the mx here, summing those two things together. Basically what we turn out is this equation right here. So I want to point something out here. This is the slope-intercept form of a line, and we refer to this, or the reason why we refer to it as slope-intercept form, is because it gives us two really important values here, which m is our slope and b is our y-intercept. And basically this is the same thing as point-slope form, but it kind of assumes that your fixed point here has to be the y-intercept, and is always at b. So we say the slope-intercept form of the equation of a non-vertical line with a slope of m and a y-intercept of b is just simply y equals mx plus b. So using this right here, the reason why we appreciate it so much is just because it is very easy to discern what the slope and y-intercept are, and also because it makes it really easy to graph equations of lines in slope-intercept form. So for example, in terms of telling what our m and our b values are, you can see a couple of equations that I've got written here, y equals 2x minus 4. It's pretty clear that this is going to hit the y-axis at negative 4, and that our slope is 2. And we could always tell that the slope is the coefficient of this x value here, okay? So that is to say, if we were to have an equation that said y equals negative 4 plus 2x, whoops, not plus or minus, but plus 2x, don't mistake the fact that the 2 is still the slope and that the b is going to be this constant value right here. Also f of x, we could use, instead of y equals, we could use f of x equals, use function notation, but we'd have, hey, like a slope of half here and a y-intercept of 2. So here's the deal. When you want to graph out of slope-intercept form, I've got three distinct steps here, but basically the first one is this. Plot the point containing the y-intercept on the y-axis. We say this is the point 0, comma b. So looking at this example over here, it says graph the linear function f of x equals 3/5 x plus 1. I think it's worth our time to even indicate right off on the side here that our slope is 3/5, that is, we have a rising graph, and that our y-intercept is 1. So what I'm indicating is that you should always start by graphing the y-intercept, and this is the point 0, comma 1, if we're going to label the point. But essentially, this is our y-intercept at a b value of 1. And then this second step here basically says obtain some other point on the graph using the slope m. And I also indicate that you want to write m as a fraction and use rise over run, and then starting at the point containing the y-intercept. So instead of starting at some random point on the graph, we're starting specifically at the y-intercept. And from here I can use the fact that our rise over run is a 3:5 ratio. So I'll go up 3. This is our rise here. I can even put like little dots here, 1, 2, 3, and then run 5, 3, 4, 5, just to show you here. But this would be some other point on our graph. And I would say, well, if I've gone up 3 and over 5 from here, this would certainly be the point 5, comma 4. And so what we'll do basically at this point, step 3, kind of says, let's connect these with a straight edge. And I'm really kind of big on that. Would you please use, if you're drawing this on your paper, a straight edge so your graph doesn't look like mine? And mine's still not as good as it could be. But I think that the best thing we want to do here before we kind of tune out of this video is make sure that we're labeling the graph. And I'm just going to call this f here because I already know that I listed f of x's rule off on the side. But I could also list the rule on the graph itself. But that's slope-intercept form, and that's really kind of the easy way to graph lines out of slope-intercept. Cheers.